J4 multiplied by 2 plus J5, you have to multiply everything. So 3 by 2, 3 by J5, J4 by 2, J4 by J5. Okay, so how does that work? 3 by 2 is going to give us 6. J4 by 2 is going to give us J8. 3 by J5 will give us J15. And then J4 by J5 will give us J squared by 20. Okay, everybody understand that? J squared, because it's J by J and 4 by 5. All right, it's all multiplied. Now here's the part that I want you to do. Whenever you see J squared, you can replace it with a minus 1. All right, and then we simplify. So you have 6 plus J8 and J15 is J23, and then you have you have minus 20. Right? This minus 20 is a real number, 6 is a real number. We can combine both of them. So we get minus 14 plus J23. All right? Now, the thing about complex numbers and multiplication is that it's associative and commutative. In other words, you can multiply any one first. So for example, we have 3 plus J4 multiplied by 2 plus J5 multiplied by 1 minus J2. All right, you can multiply any pair first and then multiply the third one. So what we did was 3 plus J4 multiplied by 2 plus J5, we get the answer from on top here. And that now we multiply by 1 minus J2. So when you multiply 14 by 1 and then 14 by minus J2 and so on and so forth, you end up with 32 plus J51. All right. Okay. I can't write on the screen, but again, we'll practice it in a little bit. So make sure you understand this here. All right. How to multiply. Okay. All right. Generally, so when you multiply two complex numbers, you're going to get another complex number. All right. Generally, when you multiply two complex numbers, the result is a complex number. However, consider the following. If we multiply 5 plus J8 by 5 minus J8, let's see what happens. 5 by 5 is 25. All right. J8 by 5 will give us J40. 5 by minus J8 will give us minus J40. And J8 by minus J8 will give us minus J squared 64. Everybody understand that? Now what happens is that this two middle terms here will disappear. And this J squared here now is minus 1. Minus by this minus sign gives us plus 1. By 64 is 64. Plus 29, we're going to get 89. So when you multiply 5 plus J8 by 5 minus J8, we get what is called a real number. All right. So to generalize that, we have that x plus jy multiplied by x minus jy always results in x squared plus y squared. Okay. So from up here, it is x plus jy by x minus jy. It's 5 squared plus 8 squared. Answer 89, right? Once we see this, we don't have to go through this long process. So x plus jy represents a complex number, then x minus jy is known as its conjugate and vice versa. Okay, now be careful, watch where the sign is. All right, so if you start off with x plus jy, then the conjugate is x minus jy. If you start up with x minus jy, the conjugate would be x plus jy. If it has a minus sign in front of the x, it doesn't matter, the minus sign stays. So minus x plus jy, the conjugate would be minus x minus jy. Everybody understand that? Okay, why do we need that? Because we cannot divide complex numbers. All right? So we can divide by a real number, yes, as we saw earlier. All right? We just divide each term by the underneath because the underneath is a real number. So you'll get 5 over 3 minus J4 on 3. All right, but division by another complex number, we cannot do that. What we do is we rationalize, meaning we multiply the numerator and the denominator by the conjugate of the denominator. All right, so in the example, we have 4 plus J5 over 1 minus J. We want to do that division. What we do is we multiply the top and the bottom by the conjugate of the denominator. The denominator is 1 minus J, so the conjugate would be 1 plus J. All right, and the underneath, remember, once you're multiplying by the conjugate, is always going to be a real number. And as you saw from before, it's just simply 1 squared plus 1 squared, which is 2. All right, x squared plus y squared. And y plus because you're going to square it anyhow. All right. Okay, and then you multiply the top normally. So it's 4 by 1. All right, and then J5 by 1, 4 by J, and J5 by J will give us this number on the top here. Minus 1 plus J9 all over 2. Again, minus 1 over 2 is minus 0.5. 9 over 2 is J4.5. Okay, so that is how we are going to divide complex numbers. So let's run through it again. To add or subtract, you add and subtract the corresponding parts. So real plus real, imaginary plus imaginary, or real minus real, imaginary minus imaginary. To multiply, you multiply everything in one bracket by everything in the other bracket, and you're looking for J squared, and to replace J squared with minus 1. And you will end up with another complex number once you combine the like terms and so on and simplify. All right, to divide complex numbers, you multiply the numerator and the denominator by the conjugate of the denominator. And the conjugate of the denominator is simply formed by changing the sign in the middle. The sign in front of the imaginary part is changed. That gives us our conjugate. All right, then we have equal complex numbers. Well, two complex numbers are equal if and only if, of course, A is equal to C and B is equal to D. All right, that's the only way they are going to be equal. All right, so let's keep going. We're going to run through all of this, then we're going to do a whole lot of examples so you'll understand it better. All right, as we said before, right, one of the terms for complex numbers is called Cartesian, and that is because we can put it on a Cartesian plane, right, an XY plane, so to speak. All right, when plotting a graph, Cartesian coordinates are generally used to plot the points. Complex numbers may be represented in a similar way on what is called an Argand diagram. The real part of the complex number is plotted along the horizontal axis or the x-axis, and the imaginary part is along the vertical or y-axis. However, a complex number is not denoted by a point, but as a phasor, right? Not a phasor. A phasor is what it is used in Star Trek, right? This is a phasor. A phasor is a line in which regard is paid to its magnitude and direction. So for these 4 values here, these are the points, all right? All right, so you have A, 3 plus 2i, B minus 4 plus 5, so you can represent it on the Cartesian plane. So these are just points here. However, an Argand diagram means that those points must be connected to the origin O and an arrow is placed on it. If you just put these points here, this is not an Argand diagram. This is just representing 4 points on a Cartesian plane. Similarly, if you draw these lines and you do not put an arrowhead, then it is not a phasor. A phasor indicates that it must have an arrowhead. So we'll have both magnitude and direction for our complex numbers on an Argand diagram. Okay, everybody okay with that? So any number that we want, so 3 plus 2i, all right, is over here. Similarly, 3 along the x-axis, 2 up the y-axis, or the j or imaginary axis. Minus 4 plus 5i would be, or j, well, it should have been j, but I just copied this diagram, cut and paste this diagram, I didn't draw it. So that's why they have I. Again, don't get confused, it's just simply I or j. All right? So again, you draw in an Argand diagram, you put the points, but the points must be connected to the origin, and you must put an arrow. Everybody understand that? Okay, good. And therefore, if you can represent it on an Argand diagram, we can then perform operations on them graphically, as we did with vectors. Okay? So again, to add complex numbers graphically, the idea would be to find the resultant. All right? So adding 1 plus 2j and 3 minus j, graphically you have 1 plus 2j. All right? And 3 minus j, you draw them, you complete your rectangle, draw the diagonal, and that's going to give you your resultant or the addition of those two vectors. Fair enough? All right, but we're not going to be doing too much of graphical representation anyhow. Here's another example. All right, we add the complex number by setting up our parallelogram, and the solution. Okay, sorry about that. I just lost connection for a second. All right, so let's continue. All right. You're hearing me, right?
Yes, sir.
Okay, great. So far, so good, all right? Nothing strange, nothing that you didn't understand. All right. So let's continue. Okay, hold up. Let's stop here for a second and let's go practice some of these things, and then we'll come back and pick it up from the polar form, because this is just another way of representing complex numbers. So let's go practice, all right? So let's work together on some of these. All right, so these are just examples. Let's add. So let's do the first one. Add. All right, let's add 3 plus J5, 7 plus J3 plus 8 plus J2. Okay. You can write what, for example, all right, you could put it in front or you could put it behind, it doesn't matter, all right? but the general style is to put j in the front. So 3 plus 5j is the same thing. You don't have to really, but get accustomed to one particular standard so that you don't run into trouble. Okay? Now, we need to add these. You could add them 2 at a time, or you can add all 3 in one shot if you want to. So it's going to be 3 and 7 and 8. That's going to give you 18. All right, 5 and 3 is 8 and 2 is 10. Answer. Everybody okay with that? Okay, great. So similarly, to subtract, let's see, 3 plus j5 minus 2 plus j8, 7 minus j6 minus 3 minus j9 and minus 3 minus j5 minus 7 minus j8. Okay, again, that's easy stuff. All right. So this is 3 minus 2, which is 1, minus, sorry, j5 minus j8 will give us minus j3. All right. 7 minus 3 is 4, minus 6 minus is a 9. Minus 9 will be plus j3. All right. And then minus 3 minus 7 is minus 10. Minus 5 j3. Okay, good. All right, let's move on. Number 3. All right, we're going to multiply. All right, so let's see. Let's practice all of these. 3 plus j3 by 2 plus j8 equals, all right, go ahead. All right, let's do it first, right? So it's going to be 3 by 2, which is 6. 3 by j8, which is j24. j3 by 2, which is j6. And then j3 by j8. That's going to give us plus j squared by 8 3s are 24. Okay. So this is equal to 6 plus j24 plus j6 plus minus 1 by 24. Good. All I did was replace j squared by minus 1. All right. And now we simplify. So you're going to get 6 minus 24 is minus 18, and 24 and 6 is J30. Everybody okay with that?
Yes, sir.
All right, try another one. So minus 5 minus J2 by 5 plus J2. All right. So this is equal to, all right, it's going to be minus 5 by 5, which is minus 25. All right. Minus 5 by G2, it's going to be minus G10, minus G10, which is this one here, minus G squared 4. Everybody okay with that? All right. So that's going to give us minus 25 minus G20 plus 4. Again, G squared is minus 1, and the minus by this minus here will give us plus. So our answer becomes minus 21 minus G20. Now I want you to notice something here. All right. Let's take a look. If I had put minus 5 minus G2 multiplied by minus 5 plus G2, there's a difference. See, here, they change the sign here and here. Down here, we change this sign alone. When we do that, this is the conjugate. So the answer here would be 5 squared plus 2 squared, which is 29. All right, let's see if it works. So I'm going to take off this here. And we're going to write minus 5 minus G2 minus 5 plus G2. All right? That's the conjugate. So it's minus 5 by minus 5. That's going to give us minus 25. Minus 5, but that is going to give us minus G10. And in here, we're going to get plus G10. And then here, we're going to get minus G squared 4. This will be plus 25, sorry. All right, minus 5 by minus 5 is plus 25. And that gives us 25. See the middle terms disappear? Plus G4, all right? Which is 29. Everybody understand that, right? So you understand the conjugate as well. Okay, so let's see. Next one. Let's do some division. All right, so we have minus 2 minus J3 over 5 minus J2. Okay. This is equal to minus 2 minus G, just, oops, be careful how you write that, right? G3 over 5 minus G2 multiplied by 5 plus G2 over 5 plus G2. Okay? And this is equal to, I remember the underneath, as the conjugate. So we can simply write quickly 5 squared and 2 squared, that's 29. See? Forget all the G and all that kind of stuff. Just square both of them. Right? Remember, it's X plus Y, JY by X minus JY is X squared plus Y squared. Good. So now we got to work out the top. So it's going to be minus 2. For now, we're going to go into our working column and work it out until we get the hang of it. So that's going to be minus 2 by 5, which is minus 10. Minus 2 by G2 will be minus J4. Minus J15. And minus G squared 6. Good. Which is minus 10 minus J19 plus 6, right? Because J squared is minus 1. So our answer is going to be minus 4 minus J19. Everybody understand now? Okay. Let's practice. Next one. So 2 plus J5 over 2 minus J5 again, the denominator is 29, all right? 2 squared and 5 squared. Now we got to go multiply out the top. All right, that's going to give us 4 plus G10 plus G10 plus G squared 25. Right? Which of course is 4 plus J20 minus 25. Right? Because remember J squared is minus 1. So our answer then becomes minus 21 plus J20. Okay, of course you can divide it using your calculator and stuff, right? I'm leaving it as is, but really we don't leave the answer like that, all right? We put it into a decimal. It'll be minus 21 over 29. Okay, and whatever that works out to be. Okay. All right. Let's do another one. One over 2 plus J5 is equal to 1, 2 plus J5 multiplied by 2 minus J5 over 2 minus J5. Okay. It's again, well, we see using the same numbers, so the underneath is the same. We got to work it out every time. But here now, the top, it's 1 multiplied by, so it's 2 minus J5 on top. Right, answer. Okay. Let's try another one. 4 plus J2 over 2 plus J by 1 minus J3. Okay. All right. Here, the first thing you're going to have to do, you'll have to multiply out the underneath first. All right, so that's going to give us 2 by 1, which is 2. 1 by J by 1 is J. Let's be consistent. So 2 by minus 3 is going to be minus J6. All right, plus J minus J6. J squared 6, sorry. Everybody with me? All right. So that gives us 8 minus J5. Did we get that? Yeah, okay. All right, remember, do it yourself, right? Please multiply it out and stuff for practice and double check what I have in case I make a mistake. So this is now going to be equal to 4 plus J2 over 8 minus J5, which is equal to 4 plus J2 over 8 minus J5 multiplied by 8 plus J5 over 8 plus J5, which is equal to, all right, we know it's 8 by 8 is 64, and 5 by 5 is 25, yeah.
Wouldn't the J by minus J3 would be minus J squared 3?
Yeah.
No, I see I put J squared 6.
Oh.
Yes, sir.
Okay, yeah, sorry about that. That's over here, right? Let's try that again. Right, so it should be minus J squared 3. Right? Actually, it was supposed to be a 3 and it looked like a 6. And Right. So this would be 2 plus 3 is 5, right? Got that?
Yeah.
All right. So then we could take this off, take that off, and take that off, and just replace it with a 5. Right? So the denominator is a conjugate, so it's going to be 5 squared and 5 squared. So that's 50. All right. Now we're going to go multiply the top. All right. So it's 4 plus G2 by 5 plus J5, which works up to be 20 plus G10 plus G10 plus G squared 20. Yeah, is that all right?
Yes, sir.
Nope, what's wrong with that? What did I do wrong, you know?
So isn't 5 by 2 10?
Yeah.
So how you get the G squared 20?
All right, good. I'm looking at the wrong thing, sorry. I should be looking at the screen and I'm not looking at the screen. Yeah, okay. That's why sometimes it's important to just draw this line. So focus on where you're multiplying. All right, so that will give us 20 minus 10, which is 10, plus J20. Agreed? The answer is 10 plus J20.
So the third one we have G10 is only 4 multiplied by the J5 is G20.
All right. All right. Well, right. So kind of forgive me this morning. I can't focus. So let's do that over. Right. My apologies, people. I shouldn't be confusing you. So let me take my time. All right. So it's going to be. All right. I'm glad some of you getting it. All right. So let's take it slowly. All right. So it's 4 by 5, which is 20. All right. And G2 by 5, which is G10. All right. And then 4 by G5, which is G20. And then G2 by G5, which is give us G squared 10. Okay. All right, so let's fix this. This will be 20 minus 10, which is 10, and 10, and that is 30. All right, so let's fix this. Okay, next one. Let me give you this one to work out. All right, so the question says there are three impedances from your physics days. Z1 is equal to 2 plus J. Z2 is equal to 1 plus J. Find Z if 1 over Z is equal to 1 over Z1. Right, you remember from impedances when they're in parallel and when they are in series. So this would be when they are in parallel. All right, so try that. Give you a few minutes, and then I'm gonna come along afterwards and check. All right, so if you're struggling, I'll start you up a little bit. So 1 over Z would be 1 over 2 plus J plus 1 over 1 plus J. Right? Now, how do you add fractions? Anybody?
Find common denominator.
Say that again, Alyssa?
Find the common denominator.
No, you're on the right track. Find the LCM.
Yeah.
All right, proceed. Well, the top is easy. So that's 2 plus J2. Well, now you got to go multiply the underneath. All right, so you run off the working column. This is going to be 2 plus J plus 2J plus J squared. Which is equal to 1 plus J3. You get that? So far, so good?
Yeah.
All right. But what they ask us to find? They ask us to find Z. what we found is 1 over Z. So therefore, we take off the top here. All right, so continuing from below. So therefore, Z would be equal to 1 plus J3 over 2 plus J2. All right, that is because A over B equals 2 over 3, and B over A is 3 over 2. Okay, you just invert both sides. All right, you find a reciprocal of both sides. So you had, all right, 1 over Z is equal to this. So you flip this side and you flip this side as well. Okay. All right, however, you're not finished because you can't leave your answer like that. It's not an answer. All right. That is still division of complex numbers. So how do we divide 2 complex numbers? All right, so you have 2 to the 4, 2 to the 4, which is 8. And now we multiply all the top. Which is 2 plus J6 minus J2 minus J6. Which is equal to 8 plus J4. Okay, everybody understand this stuff? Okay, so let me give you a challenging one to do. Take your time. I'll give you the answer. Let me see if I can find this question. All right, so we're going back with the same stuff, right? Z1 is equal to 2 plus J. Z2 is equal to 1 plus J. Z3 is equal to J. Find, oh, excuse me. Okay, try that. But we already worked out what is 1 over Z1 plus 1 over Z2. So you got to go back to that. right? So good mark here. All right, take your time, give me an answer for that. 9, 1. Right, what did we get for Z1? 1 was Z1 plus 1 was Z2. Two plus J2 over 1 plus J3. All right, notice I'm leaving the Z3 here for the time being. All right, we'll replace it in the end. Now we got to work this out here. All right, well, of course, that is given to us here. One plus J05. right? And then we have to add Z3, which is G. Okay, everybody understand that?
Yes.
Okay, good. All right, so let's move on. Let's go back to our notes. Let me just switch screens. Everybody finished with the screen, right? Right. Right. So we're going to go back here now to the next way. This is the second form of expressing a complex number. Okay. Again, you're familiar with all of this. We did it in vectors and stuff like that. So if we have a complex number called Z, all right, and it's represented by the phasor OP as shown in the diagram in the red line, all right. Remember, complex number is represented by a phasor, right? It has to be joined to the origin, must have an arrow on it, okay? And it's xy. And this vertical distance y here is simply r sine theta, okay? Sine theta is the opposite over the hypotenuse. So the opposite would be y, would be r sine theta, and the magnitude of r, all right, would be the square root of x squared plus y squared from Pythagoras. Okay, so from the right angle triangle PMO, right, y is r sine theta, and x value would be r cos theta. Everybody okay with that? From this triangle here, we're using sine and cosine. Sine of theta is opposite over hypotenuse. So opposite is r sine theta, right? X cos theta would be the adjacent over the hypotenuse. So the adjacent would be r cos theta. All right, we write it like this: x plus jy. X is r cos theta, y is r sine theta. You include the j, so we'll get r cos theta plus j r sine theta. We factor out the r, and we write it like this: r into cos theta plus j sine theta. And this is known as the polar form of a complex number. Some books, you'll see them write it like this: Z is equal to r with this sort of symbol here and theta. All right? R is called the modulus of the complex number, and it's noted by two straight lines. And from the diagram, hence, the modulus of R is by Pythagoras, the square root of x squared plus y squared. The angle theta is called the argument or amplitude of the complex number Z, and is denoted by ARGZ or argz. And from the diagram, tan theta is opposite over adjacent. So to find this angle theta, we're going to use y over x. Okay, let's see if you can figure this out before we move any further. We're given a complex number z equals x plus jy. All right, this is the Cartesian or rectangular form. To convert it to polar form, we work out r and then we work out theta. Okay. So in polar form, it will be r cos theta plus j sine theta. To work out r and theta, you work out r by using Pythagoras, and you work out theta by using tan theta equals y on x. In other words, theta is tan inverse y on x. Okay. All right, it is called the principal value and it lies between minus 180 and plus 180. When finding the polar form of a complex number, you should sketch it on an Argand diagram to avoid common errors as we saw last time with vectors. Remember, we got to make sure which quadrant it's in, because if you use the wrong quadrant, then theta would be the wrong value. Okay, so let's go back up and check that. Let's look at the examples. Find the polar form and represent graphically the number 7 minus 5j. So we find r first, which is approximately 8.6, right, using Pythagoras. To find theta, you find tan inverse of y on x, which is approximately 35.54 degrees. Now, 7 minus 5j is in the fourth quadrant. So the angle that we really want is 324.46 degrees, as we saw last time from vectors. So expressing 7 minus 5j in polar form, right, you have 7 minus 5j is equal to 8.6, which is r, into cos theta plus j sine theta. Okay? If you use your calculator to go in the reverse direction, if we work out 8.6 cos theta, or something, that's a typo there, right? Yeah, we're missing out the sine part, right? The j sine part. So we can write it as, again, remember we use the symbol in the middle here. So stick with this. All right, r cos theta plus j sine theta. All right, and then we represent that on our graph down here. If we were to use 35.54, you'll see on your calculator you're going to get positive values, which means that your phasor is going to be in the first quadrant, and that's going to be wrong. Okay, so it's critical, as with vectors, that we identify which quadrant it is in, so we will know what the angle is. Now, to go in the reverse direction, if we want to go from 8.6 cos 324.5, etc., to rectangular or Cartesian form, we just work it out on our calculator. So try this. 8.6 multiplied by cos 324.5. See what you're going to get. 7. And 8.6 multiplied by sine 324.5. You should get 5. Let's check it and see. Calculator. All right, so it's 8.6 multiplied by 324.5. Cosine. All right, so it's, let's see, 8.6 multiplied by It's wrong. This angle here wrong, isn't it? Check it and see. Tan inverse is point. Oh crap. I'm working in radians. Sorry. I tell you, I'm not really functioning this morning, so bear with me. 5 divided by 7 equals to that. Tan inverse 35.5. And then we go down to 8.6 multiplied by 324.5 cosine, which will give us 7, and 8.6 multiplied by 324.5 sine will give us -5. Okay, all right, so that's correct. And that's the graph. Second example, in this case, it's in the third quadrant. All right, so express that in rectangular form. All right, we just simply work out 3 cos 232 on our calculator and 3 sine 232 on our calculator, and we're going to get the answer. All right, everybody okay with that? Example 3, represent it graphically and write it in polar form. Okay, same thing. And then you have example 4. So you have all those examples there. 5. All right, so you can go through all of those examples when you get some time. I'm just going to bring up some questions that we can do. What comes in exam? All right, multiplying numbers in polar form. All right. So sometimes you're asked to multiply numbers in polar form. This is how you do it. All right. You multiply the modulus okay, and you add the angles. All right. So for example, you have 6, all right, into cos 17 plus j sine 17 plus 3 into, you just simply multiply the modulus and add the angles. To find the square root, right, you find the square root of the modulus and you divide the angle by 2. And to divide two polar numbers in polar form, two complex numbers in polar form, you divide the modulus and subtract the angle. All right? Okay, we're going to practice these so you get a hang of it and the application of it. All right, and the last thing is that there is a third way of writing a complex number, and that's in exponential form. All right, so r cos theta plus j sine theta, we write it as this. The same r here is the same r over here, except that theta this time, whatever theta we have inside here, we'll convert it to radians and write our answer as reg theta, where theta is in radians. Okay? And these would be the 3 forms: the rectangular form, the polar form, and the exponential form. All right? So let's go see how to apply these, get some questions. Just 1 second. How's the time? All right, let's take a 15-minute break, people. We start back at 9:45, and then we'll do some possible questions. In the meantime, you could just run through it if you want. All right? So just give me a 15 minutes. No. That's a way, that's a way. Wait till the voice.
Take medication early and drop the medication early and I can do it at 8 o'clock. So it actually got something out. Anything out of here, please? Well, I can't complain it to somebody, you know. Tablets. Other medication, tablets for the painkillers. Tablets for the painkiller. Nothing for this. It says get pain down, swell down, and scardia. See how much of an answer is still taking for. That's the basis for this.
Yeah. No, pero yo no pasa en el momento.
Yeah, but still, I'm step on the we have an ambition. Sip, 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 sip. Hopefully. Avoid this.
Oh.
By going and taking a blood work, I keep telling you that pick up uric acid. Will not have to not to be this. You're going to give it a manage now, change whatever it is one time. Prevention, prevention. We have to get this controlled.
Listen.
What was it now? How about it's a book title. But that's a brother who tried to travel to come and try this. Yeah, the same way we can't get you guys stick.
Is it? You try it?
It's stick.
You try it?
Yeah, fine. It's stick. I mean, I could use it if we can't.
You got it fast. See what you have.
Yeah, it's something. Worthy thing. Oh. Put a check box in. You could turn on the side, that's okay. Just could turn here, and I could turn so, and you could turn on the side. Someone and it's just I think like a water. So when you get that in the wash to drink and yeah, make it. As I said, I'm just like myself to the papers like get up in the fashion drink
Betul. Atau juga aku tapi apa? Yang resmi.
Well, that's how it is placed. But it's like you have to do it. You have to do what needs to be done. You have to show us a bit of this. It could be either one. Some people have all. You see pre-diabetes, diabetes, dehydration, drinking water, overweight, genetic. That's it. Yeah, that's it. That's it. No, any diet. Some people even to pinpoint 1 or 2, just have one, and people have more than one.
Ya, dengan saya.
Okay, shall we resume? All right. Okay, guys, you can hear me, right? Let's start.
Yeah.
Okay, great. All right, so let's take a look at some classical questions. You see how easy it is? Remember, this is 10 marks out of 50 in the exam. So watch how easy you're going to make these marks. All right. So this question says, Z1 is equal to 2 plus 8 J8 Z2 is equal to 1 minus J, part A. Find Z1 over Z2 part B. Find part C, express both Z1 and Z2 in polar and exponent form. All right. So you're given Z1 is equal to 2 plus J8. Z2 is equal to 1 plus J. Find Z1 over Z2. And find the modulus of Z1 over Z2. And express both Z1 and Z2 in polar and exponent form. So this was 3 marks. This is 1 mark. And this was 6 marks. Who said this question? I would love to know. All right, I'm giving a second or two to work it out. All right, so Z1 All right. Well, we know what we have to do. All right, and as I said, you go ahead and work. See if you come up. All right, remember the denominator is reconjugate, so it's 1 squared plus 1 squared. And then the top, we need to work that out. So that's 2 plus J8 plus J2 plus G squared 8. Yeah? All right, as easy as that. And part B. Right. It says express both Z1 and Z2 in polar and exponential form. Everybody okay with it so far? No problems, right? Okay. Next page. All right. So the one Z1 is equal to 2 plus J8. All right. So R will be the square root of 2 squared plus 8 squared. And theta tan inverse 8 over 2. All right, which is equal to so 68 square root. So that's 8.25 and 76 degrees. I'm just going to round it up, right? Did you get that? Okay. All right, now watch this, right? Pi radians is 180 degrees. I'm gonna write properly now. Okay. Pi radians 180 degrees. Okay. So 1 degree is pi over 180 radians. So 76 degrees would be pi by 76 over 180. Which is equal to 1.33, right? Oops. .33 radians. Oh, this thing right angle at all. Right. So watch this. So therefore, Z1 equals 2 plus J8. Well, we didn't need to sketch this because 2 plus J8 is first quadrant, so we don't have a problem. All right. It's going to be equal to 8.25 Everybody understand that? So this is your polar form. This is your exponent form. Yeah. All right, let's work it backwards and see. So we go to our calculator. So it's going to be 8.25 multiplied by cos 76. That's going to give us 2. And 8.25 multiplied by sine 76. That's going to give us 8. All right. Now, for the exponent 4, make sure your calculator is in radian mode. And then it's going to be 8.25 multiplied by cos 1.33. So you get your 1.9, which is 2. And 8.25 multiplied by sine. You're going to get 8.01. All right, everybody understand it? Okay. Let's see if we can figure out the second one, which is Z1. Z2 is 1 minus 1. Ooh. Let's see, that's tricky. Let's see. So R would be the square root of 2, which is 1 squared plus 1 squared. All right. Theta is tan inverse minus 1 on 1, which is all right, 45 degrees, right? But notice that you're going to get minus 45 degrees. Tan inverse of minus 1 would be minus 45 degrees. Right. So now we got to check and see where is this. So this is in fact in the second quadrant, right? Because the x value is, sorry, wrong. What am I doing? So the x value is positive, the y value is negative, so it's in the fourth quadrant. All right, 1 minus 1. So our angle is in fact 360 minus 45. All right, 315 degrees. So agreed? Okay, once again, let's double check that it works. Make sure you are in degree mode. So it's going to be square root of 2 multiplied by cos, which is going to give us 1. And the square root of 2 multiplied by will give us -1. So we're in business, okay? All right, and then we use the same strategy. Pi (180 degrees) is pi radians. So 315 degrees would be pi over 180 multiplied by 315, which is equal to um, 5.5 approximately. All right, so this is your polar form and this is your exponent form. Okay, everybody comfortable with that? Everybody understand exactly what we did? No problems, right? Good. All right, let's do another one. That's your 10 marks. So easy and so fast. Okay, so we'll do another one. Z1 is equal to 1 plus I, well, 1 plus G over 1 minus G. Z2 is equal to 1 over 2 plus square root of 3 all over 2 G. Show that Z1 is equal to G. All right, let's do that one part at a time rather than writing them all. So what do we do here? Anybody? Yep, exactly, divide. So Z1 is equal to 1 plus J over 1 minus J, which is equal to 1 plus J multiplied by 1 plus J over 1 plus J. Right? Which is equal to so we're gonna get 1 plus 2G plus J squared. Right? Which is of course 2G. That's for the top. Because this is minus 1. Minus 1 and 1 will disappear. Right? So we're going to get 2J on top. All right? And the underneath is going to be 1 squared plus 1 squared, which is 2. J, answer. Get on. Any questions? All right, next part. All right, so part B. Show that all right, so from part A, Z1 is equal to J, therefore is equal to 1. All right, now but the real part would be 0. All right, remember it's 0 plus J. 0 plus 1J if you want. All right, so it's going to be 0 squared plus 1 squared. H squared of 1 squared is 1. Now for Z2, Agreed? Okay, excellent. All right, part 3. Express Z1 and in both polar and exponent form. All right, so for Z1 is equal to, we know that is equal to J. All right, there's no need to go back here and work with that long thing when we already know that is equal to J. All right, we showed that in part A. So use that instead of going back on top and working back all of that stuff. And then we just worked out that the modulus of Z1 is 1 anyhow, so we just need to work out theta. And that's tan inverse of 1 is it? All right, so the problem here that we faced with is tan inverse of 1, remember, it's going to be y over x, and y is 1, but x is 0. All right, remember, it's here, all right, g. The x value is 0, and g is 1. All right, so the angle is in fact 90 degrees. Yeah. So theta here would be 90 degrees. That's good. So if you check on your calculator, all right, tan of 90 degrees, you're going to get an error. And that is because 1 over 0 doesn't exist. All right. So the actual value is going to be 90 degrees. All right. So in exponent form, it's going to be 1 cos 90 degrees plus J sine 90 degrees. Again, if you use that on your calculator, you will see cos of 90 degrees is 0. So 1 by 0 is 0. And sine of 90 degrees is 1. So we're going to get J, right? Which is our original. Everybody following me?
Yes, sir.
Excellent. Thank you for the feedback. Great. All right. So what about in polar form? Sorry, in exponent form. So this is polar form. So in exponent form, 90 degrees, remember, 180 is pi. So 90 is pi on 2. All right. So in polar form, it's going to be 1 e to the j pi on 2. All right. There's no need to work it out. All right. So in polar form and in exponent form. Okay. All right. So do the next part. Put Z2 in polar form and exponent form. Give you a few minutes to work that out. All right. We're supposed to be the J first, but never mind. Well, we just shown in part B, all right? We show that the modulus of Z1 is equal to the modulus of Z2, which is 1. Right? All right, so now we need theta. All right, tan inverse root 3. All right, tan inverse root 3, 60 degrees. And 60 degrees is pi on 3. Right? So far, so good?
Yes, sir.
And the last part says Z1 and Z2, put it on an argon diagram. Right? So part D of the question says express Z1 and Z2 on an argon diagram. Now watch here carefully, right? This here, we've already shown that that is equal to J, right? Because you can't put this as is on an argon diagram. You have to do the division in any case. So, all right. Let me just draw that back. All right, remember that's J and this is our X. So that is going to be Z1. Right? Remember there's no real part. It's only the imaginary part, and that's 1. Right? 1J. And for Z2, it's going to be, this is 1, this is 1. So it's going to be a half. So that's going to be somewhere here. Right? So this one is Z2. Right, you can draw it better than that, right? I'm just trying to save space here. All right, that's pretty easy. Remember what I said. All right, on an argon diagram, you have to connect the point to the origin O, and you have to draw the line. You have to put an arrow on the line. Okay? Right, so that's another question that was 10 marks. Let's see if we can find another one. All right, so let's see. Two x squared All right, so the question says, given the equation 2x squared plus 3x plus 5 equals 0, find the roots. All right. Okay, that simply means find the solution. The solution of a quadratic equation is called the roots. All right. So using the quadratic formula, you have the quadratic formula with you. Work out the roots of this equation for. And tell me what you get. All right, take your time. But it's minus b plus or minus. Anybody? One second. Sure? Check that out. Minus 3, this should give you minus 0.75 plus or minus 1.6. Okay. Square root of 39 divided by 4 by 1.56. Heck, did I get 1.4 here? Okay, so that would be your answer there, right? Find your roots. So
Excellency.
What do wrong?
G3 squared minus 4, right, sir? When I work out that with all doing the square root, I get 31. Minus 31.
Yeah, okay, that's correct. Yeah, my calculation wrong. Yeah, this is supposed to be 31 here, not 39. 40 minus 9. 40 minus 9 is 31. Thank you. All right, so this would be 1.4 instead. Okay. Let's check that again. Yep, 1.4. Right. So the question then says, call 1 root alpha the other beta show alpha plus beta what is 2.2? No, the square root of 31 divided by 4 is 1.4. Isn't it? On my calculator. 7269. Phone. 31 square root is 5 point whatever. Divided by 4 is 1.4. Okay. So it says call one of the root alpha. So we'll call this one alpha. Call one of the root beta. And show that alpha plus beta is minus b on a. Okay. So therefore 0.75 plus, oh boy. Agreed? All right. It's minus 0.075 minus 0.075 gives you minus 1.5 plus J 1.4 minus J 1.4 will disappear. All right. And this is equal to B minus B over A, which is from up here, minus 3 over 2. All right. Now, how is it? Why is this important? I'll show you in a second. All right. So hold on to that thought for a minute. And alpha multiplied by beta would be equal to right? And we realize that that is the complex conjugate. So all we have to do is to work out squared plus what we get? Point 0.75 squared plus 1.4 squared is equal to 2.5. All right, and C over A is 5 over 2. All right, from up here. C over A. All right, which is 2.5. Okay. Now there's a reason for that, and that's the next part of the question. All right. And it says here that, you can write this down, keep this note handy. Any quadratic equation can be written in the form x squared minus the sum of roots plus, x plus product of roots equal to 0. Right? And that's what we just saw. Right? Our equation was 2x squared plus 3x plus 5. All right. Okay, this here is sum of the roots. When we worked out alpha plus beta just now, we got minus 3 over 2. Okay. And alpha by beta was 5 over 2. How does that work? Watch this, right? We have to write this. Remember this is the formula. So it's going to be x squared plus 3 over 2 x plus 5 over 2 is equal to 0, right? This 2 here, we divide everything by 2 to get that. All right. sorry, plus. So alpha plus beta would be minus, right? Sum of the roots. And alpha multiplied by beta would be the product of the roots. Okay? All right. All right, so last one. Express right? Express minus the square root of 3 plus j by 4 plus j4 in polar and exponent form. All right, let me read that again. Express minus root 3 plus j plus 4 plus j4 in polar and exponent form. All right, which means that we have to multiply this first. All right. Okay. So what I wanted to show you here was this, right? Let's do it the other way around. Let's do it the other way around, right? Minus root 3 plus j in polar form. Okay. So r is equal to the square root of minus root 3 all squared right? You with me? Right? This square root of 3 squared is 3. 3 and 1 is 4. Square root of 4 is 2, right? And theta tan inverse 1 over root 3 minus, which is
This is exactly why I'm never giving an iPad to my kids. No more iPad. This is exactly why I'm never.
agreed? Everybody with me? All right, so once again, let's check and see where this thing is. So it has to be over here. All right. So it'll be 180 minus 30, which is 150 degrees. All right. So it's so in polar form, agreed? All right. Let's do 4 plus J4. So R would be the square root of 4 squared plus 4 squared. Theta is tan inverse 4 over 4. Which is 45 degrees. And R would be 5.66. All right, now check out the formula. What do we do when we are multiplying? In the notes, find the formula when you're multiplying complex numbers in polar form. What was? All right, remember, it's going to be multiply R's. This is going to be 5.66. What was the what it was just now? 2, right? 150. All right, and then we have to add the degrees. So answer is And that's the shortcut. Basically, it's really right, which is equal to so .08. Okay, everybody understand these things? All right, so that takes care of complex numbers. All right, I'll send you a worksheet to do on complex numbers. All right. Any questions, comments? Everybody okay?
No, sir.
Guys, yeah. All right, great. So we've stopped there then. All right, that takes care of complex numbers. So I'll send you details on the questions for the quiz next week. All right, because it's going to be on vectors and complex numbers.